questions about what they're doing.
Yeah, I don't ask questions.
Okay, let's get started. Lesson 1-6 is all about relations. Relations are talking about ordered pair. A group of ordered pair is called a relation. It can be two or more ordered pair together. There's nothing special about them. They don't have to be a certain anything to be considered to be a relation. And so this is how a relation would be written. It's just a bunch of ordered pair held together in set notation, the brackets. That's called set notation. There's more than one way to represent a relation, and here we have 4 examples. One is to just list the ordered pair, which is what was done here. All we did was stack it. We didn't change anything. We didn't change their order. The ordered pair 2, 3 is 2, 3. Negative 4, 2, negative 4, 2. 1, 4, 1, 4. So is that difficult to do? No. Can it be time consuming? Yes, and that's what's going to happen with your homework today. It's not going to be overly difficult, but it's going to take a little bit of time. Okay? Now, the other way to represent a relation is you would take the values that were in the ordered pair and you could put them on a graph. How many of you are comfortable graphing? How many of you still kind of struggle? Which direction's X, which direction's Y? No? Yeah, y'all are not telling me the truth, but okay. When you have the ordered pair, and this is the X value and this is the Y value, the X's will always go sideways and the Y values will always go up and down. If it's a positive number, it would go up or to the right. If it's a negative number, it would go to the left or it would move down. And so if you struggle with which way you're supposed to go, this isn't a bad example to use. So if I was going to graph these ordered pair onto this coordinate plane, this 2, 3, the 2 is the X value, so it's going to go sideways, and it's a positive 2, so that means it's going to go to the right. So I need to go from the center 2 spaces to the right, and the 3 is positive. I would go up 3 spaces. The negative 4, 2, the X is negative, so it's going to go backwards 4, but the 2 is positive, so it goes up 2. At 1, 4, and then at negative 3 and negative 5. Okay, so that's 2 ways that you could write a relation. A table is a third way that you could write, and a table is real straightforward too. It's nothing fancy, no rules or anything like that. And the table truly just takes the ordered pair and puts all of the X's in one column and all of the Y's in another that actually went together. So notice this X is a 2, the Y is a 3. This was the 2, this was the 3. So all you're doing is transferring this into a table form. You're okay with that? Okay. The only thing that may be different and what you've maybe not been exposed to before is something called a mapping. A mapping is when you take your X values and you stack them like this, and then you take your Y values and you stack them. Then you draw arrows to make them match. I'm going to ask us to do something a little bit different to this one. I would like us to put this in order from least to greatest with no repeats. If we start doing that now, when we get to the lesson on Tuesday and Wednesday, you'll already be understanding what's going on. And that would be really helpful to you to not confuse you and do it one way one time and then another way another time, okay? So let's try to put our numbers in order when it's in a mapping from least to greatest and with no repeated values. So I'm going to ask you to see if you can somehow maybe draw a little smaller eggs here, a little smaller mapping. This is going to be your domain and this is going to be your range. And let's rearrange the domain numbers so that they're in order from least to greatest. So what's the smallest number in this domain? a -4. So we would put it first. What would come next? -3, and then a 1, and then a 2. Okay? So we listed all of our domains, all of our x values together. Now let's do the same thing with the y values, putting them in order as well with no repeated numbers. So -5 is going to be the smallest. Then we have a 2. Then we have a 3. And then we have a 4. Okay? Now, the whole arrow business is how they are mapped to each other. Meaning, if I go back to the original pairs of numbers, the 2 belonged to the 3. So I need to map the 2 to the 3. Okay? So this 2 draws an arrow to the 3. This was the x, that was the y that created the ordered pair. I have a -4 to a +2. So here's the -4 on the x, and we draw a line to the +2. I have a +1 and a +4 together. So the 1 gets drawn to the 4. Bless you. And then I have a -3 that's mapped to the -5. That would be a proper way to do it, and it'll keep us from getting confused later on, okay? You know, this is a mapping, but it's really not technically the way it needs to be. Are you okay with this so far? Yep. All right. This is what your homework is going to ask of you, okay? Express the relation as a table, a graph, and a mapping. So let's do it. Actually, your homework's going to ask you to do 4 things. I know. And we're going to do the 4th thing at the bottom. And it's just listing the domain and range. So let's do these 3, and then we'll add the 4th one, and you'll have an example of what your homework will look like. Okay? So we're going to draw a table. So the x and then the y, they're alphabetical. And here are our values. A 2 and a -1. A 3 and a 4. A -1 and a +1. And then a +3 and a +1. That's all you had to do was write the ordered pair in a table. You okay with that? You okay? All right. Now we're going to do a graph. Yes, sir.
You have to box it in.
I'm not that picky. If you want to put a box around it, you can. As long as you have the T part of it, I'm cool. Okay? All right. So now let's do a graph. So we need to label our x and y axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And plot your points. +2, -1. A +2 to the right and down 1. 3, 4. They're both positive. So to the right 3 and then up 4. -1, +1. Backwards 1 and up 1. And then +3, +1. So they're both positive again. So +3 and a +1. Your point should look something like mine. Did you do okay? Stephen, you good?
Yeah.
Okay. Does anyone have any questions? Okay. Now let's try mapping it, and remember the rules. Least to greatest, no repeats. So here's one mapping and the other one. Domain and range. How many, do you remember which one's the domain? Is it the x or the y? X. How many of you will forget that and get it confused? I have something that will help you if you'll admit it.
Do it.
Okay. X and Y are alphabetical, right? If you say X and Y, the ordered pair are alphabetical. So if you have an ordered pair and you write them like this, would you agree that the words domain and range,
All of that order.
they're alphabetical as well? And so they will line up perfectly if you get confused. It's kind of an easy, just a helpful hint, okay? So now, let's list all of our X's from the domain in order, least to greatest, but no repeats. So what's my smallest value? -1, so I took care of that guy. Looks like I've got a 2, a 3, and a 3. So I just need a 2, and I need a single value of 3. Okay? We're going to list our Y values now. Same thing. In order least to greatest with no repeats. Okay, so I got a 1, a 1, a 4, and a -1. So I have a -1, a +1, and a 4. Now remember, once you've listed them, you got to draw lines so you know who goes to who, right? So the +2 went with a -1. So draw a line. The 3 goes to the 4. The -1 goes to a +1. And then the 3 goes to the +1. And it's okay if they might have 2 or 3 going out of the same number. It's okay. You comfortable with that so far? Any questions? All right. Fairly easy, just time consuming. I mean, it really isn't horrible, okay? And this is a little bit of review that we just did. The blank is the X value. Domain. Domain. And the rangy is the Y value. Okay? The one other way that you can list a domain and range, okay, our mappings do the domain and range, our circles, right? Or we can list them in set notation with the brackets. The rules are the same whether they're in our eggs, our mapping, or the brackets. The rules are the same. Least to greatest, no repeats. So once you get the hang of that, it's very easy. And so let's try it. Let's do the domain values. So we're going to list all of the X values in order, least to greatest. So I've got a -2, a 5, a 2, and a 2. Who's the smallest?
-5.
Oh wait, maybe I said it wrong. A -2, a +5, a 2, and a 2. So -2 comes first, +2 comes next, and then a +5. And you're done. You've listed the domain. Now we have to list the range. Now we're looking at the Y values. -5, -3, -1, and a +4. Is that right?
Yeah.
Okay, what's the disadvantage of just listing them using this method? You don't really know who went with who. So you would have a very difficult time rebuilding the ordered pair this way, wouldn't you? Because you don't see who belonged to who in the ordered pair. The mapping, however, it's very easy to put those guys kind of back together like a puzzle. You can undo it. So just know that that's a disadvantage of the listing. See if you can do this list all by yourself real quick. And then we're getting real close to being done with the notes. All right, that's what you should have gotten. The domain should have been a -1034, And then the range should have been a -2, -1, 3, and then a 6. You doing okay? All right, flip it over. Now we're going to go to the thing that I have struggled with all my life. Dependent and independent variables. And okay. How many of you have a hard time identifying what's dependent? Me too. I'm not even going to lie to you, okay? I hated these things. I finally kind of have an idea. After teaching, you learn. The best way to learn something is to try to teach somebody else. You figure it out. It's amazing how much that works. Here's a sentence that has helped me greatly with understanding these. Some people are amazingly good at this right off the bat. I am not one of those people. This sentence right here, y depends on x, is incredibly helpful. Because whenever you get started, the y is going to depend. So y will be your dependent variable. Okay? So look at this example here. The dance committee is going to sell some tickets to the ball. The more tickets that they sell, the more money they will be able to spend for decorations. Please determine which one is dependent and independent. So I'm going to go, okay, do the number of tickets depend on the decorations? Think about it. Are people going to buy a ticket because they're excited to see the decorations? That doesn't make sense, does it? So that can't be the order, so let's change it up. The decorations depend on the tickets. That makes sense. So the decorations depend. So decorations is the dependent variable. And the tickets will be the independent variable. See if you can figure out which one's which on this air pressure. The air pressure in a tire increases with temperature. The air pressure on a tire increases with the temperature. So does the pressure depend on the temp? Or does the temperature outside depend on the air pressure in the tire? So it's going to be y depends on x. So which one makes sense there? The temperature outside depends on how much air you put in your tires. If that's the case, everybody inflate your tires so that we have a lovely, 80 outside for the rest of the year? I'd really enjoy more.
We could all deflate our tires so it'd be winter.
Well, there we go. Okay, so I don't think that'll work, will it? Okay, but the pressure of the tire depends on how hot or cold it is outside. That makes sense. And so this is the correct way. So y depends. So the pressure is the dependent. Pressure, that doesn't even look right. I don't know, maybe it is on the air. Oh, temp. Okay. So y depends on x. X can come on really handy. Last thing is real quick is to describe this sketch. These are called sketches. Notice there's no tick marks, there's no numbers, it's just on the axis is words to describe what's happening. If you notice here, this is time passing. Time is increasing as it goes to the right, and the distance is increasing as it goes higher. So what's happening here, let's pretend I'm riding a bicycle. It could happen, okay? And as time is passing while I'm riding this bicycle, what's happening to my distance? I'm going somewhere, right? So I'm adding miles to my bicycle. Then what's happening right here in this flat line? Well, I can't be cruising because my distance isn't changing, but the time is still passing.
So you're chilling.
So I probably am having a small heart attack from not riding a bike very often. That's probably what's happening. I'm stopping at a picnic table to catch my breath. Okay? Not even going to lie there. Okay, so now I'm moving again, aren't I? Because my distance is changing once again. So I could be doing one of two things. I could be heading back home, because that's still going to put miles on my bike, so my distance would still be changing, or I could be heading to the hospital on my bike, depending on the situation, right? So but what I want you to not make the mistake of is just because this is going up and then it's going up some more, that doesn't mean you're getting further away from anything. It just means you're putting more miles on your bike or whatever it is. Because coming back to the house would still be putting miles on my thing, so my distance would still be increasing, even though I might have come back home. Does that make sense?
So if you pedal backwards, it would be decreased.
We wish that would happen, yeah. See if you can describe this one. Okay? Oh, so the answer here says, as time passes, the distance increases, then it doesn't change, then the distance increases again. Notice that they're using the words on the axis in their description. A great answer will use both of those words. So see if you can describe what's happening here using these words. And then we'll see if you can give me an example of what could fall into this category. So what's happening to that temperature? Okay, so the temperature is decreasing. The temperature decreases as time passes. Perfect. You used both words. Okay. But then what happened from here to here?
The temperature stayed.
Okay.
It's the same over a period of time.
Yep, so the temperature then remains constant. We'll use big words. All right, so then the temperature remains constant over time. Give me one example of what could do this. Yes, sir. Cole.
My refrigerator.
Your refrigerator.
Oh, your house.
Okay, so like when you put the doors open or something, the temperature might start out a little too high,
Yeah.
and then it kicks back in and kind of maintains your food at a pretty constant temperature. That's not a bad example. Yes, ma'am.
Like, you know when you like first get in your car and like your AC's not
Oh, I like that. Yeah, I know. Yeah, you about want to cry when you get in, turn into a little sweat ball. Yeah. You know what I thought of?
Super cold, just sweat, like, freezes on you.
Yeah, I thought of chocolate chip cookies coming out of the oven. They're too hot when they first come out of the oven, but then after about, an hour or so, they hit room temperature and they're just right. Good chocolate chip cookies. Gotta love them, right? All right, so this is going to be your homework. It's not overly difficult. Yes, you have homework on the weekend. Please do not cry.
I have to sing the Spanish alphabet.
A, B, C, D.
I have to go to the game.
When. Okay, listen up. Guys, listen up. You've got 10 minutes or longer. What time you get out here? 12:26. You have 13 minutes. You can get half of this homework done if you will quit complaining and get busy.